Good afternoon, everyone. We are Group 6, comprising of student ID 102, 111, 120, and 125. Our project is Bangla Digital Clock that we will be demonstrating now. Here is the outline of our presentation. We designed an English digital clock initially and upgraded it to Bangla eventually. We used ATMEGA8 microcontroller for building the clock and Micro C Pro for AVR as our compiler. The project was simulated in Proteus. 8.10. 8x8 dot matrix LED has been used as a display, and in the end, a PCB layout has been designed for hardware implementation. We see digital clock almost everywhere. However, the same is not applicable for Bangla clocks. The usual 7-segment displays are not designed for Bangla language and cannot display Bangla number fonts. The objective of our project is to construct a system to mitigate these issues. For this project, we used diodes, a decade counter for counting in decimal digit, 4 shift registers for storage and movement of data, serial real-time clock. The project was constructed using ATMEGA8, a low-power CMOS 8-bit microcontroller, and it was simulated in platform Proteus 8.0. Now Suba will explain the algorithm of our project.
Thank you, Moon. Good afternoon, everyone. I will now explain the algorithm of our Bangla Digital Clock project. For this project, we have used ATMEGA8 microcontroller. At the beginning of the program, the DS1307 serial real-time clock reads the time from the PC clock. This value is passed on to the ATMEGA8 microcontroller. The microcontroller uses a font algorithm to convert the time into a hex value to display in the dot matrices. The font algorithm will be discussed in the next slide. With the help of a decade counter and 4 shift registers, the desired numbers are displayed in the dot matrices. During the execution of the program, if the set/change switch is pressed once, an interrupt occurs. This is used to set the time of the clock to any desired value. The first digit is adjusted using the adjust switch. Then the shift switch is used to move on to the next digit. This procedure is repeated until all 6 digits have been calibrated. After this, the set switch is pressed again and the control returns to the main program and the clock starts counting again. To display a single font, we have used 8 rows and 5 columns of a dot matrix. The fonts are converted to a hex number as follows. Suppose we want to display the Bangla digit 1. For that, the dot matrix output should be something like this. Here, C1 can be represented with an 8-bit binary number. The first row contains the LSB of the number and the last row contains the MSB of the number. This binary number is converted to a hexadecimal value. In the same manner, the next 4 columns are converted to 4 hexadecimal numbers. Here, notice that the 5th column is an all 0 column. This is used to put space between 2 consecutive digits. These 5 hexadecimal values are used to represent the Bangla digit 1 and are stored in a matrix. The same procedure is used for all the digits. Now Farhan will demonstrate the procedures.
Thank you, Suba. Hello. Now I'm going to demonstrate the project in real time. We can see a DS1307 real-time clock that passes the clock information of my device, that is my PC, to the ATMEGA8 microcontroller, as we are using the common column cathode to display the digits in the dot matrix LED. 14017 IC is used to activate the columns and 4 4094 ICs are used. Each 4094 is used to assign high or low values to the activated columns. Support column 1 is activated by 4017, and now 1R1 to 1R7 will decide the 8-bit logic of the corresponding column. If we open the code, we can see several hexadecimal values are stored in a matrix called number font. As Suba explained earlier, each digit is displayed by 5 columns, and we have a total of 10 digits and corresponding hexadecimal values are stored. So if we run the program, we can see that the clock takes the real-time value from our clock, which is 2:45 AM, but the digits are in English. We have changed the matrix values according to Bangla and again run the program. So here we have finally built a Bangla digital clock. Now we can change our initial time. If we press the set button, it will deploy interrupt operation, and with the help of adjusting and shifting button, we can change the digits. Pressing the set button will start the clock. In case of power failure, the clock count will go on, but it won't show anything in the display. However, it will catch up with the real-time clock values as soon as the reset power down button is open. Now, Ankon will demonstrate the PCB designing part of our project.
Thank you, Farhan. Now I will demonstrate the PCB layout design of our circuit, which we have built using Proteus 8.10. For the PCB design, we need to have inputs and outputs, and so we have added a 2-port connector to include VCC and ground in our circuit. We shall be incorporating the external dot LEDs with this PCB layout. So for those dot LEDs, we have included adequate number of connectors. Now let us move to the Proteus circuit. Now be fetching the PCB layout. This is the PCB design of our circuit, and on the right side, we can see the connectors which are expected to be connected to the dot LED matrices for a hardware system. The other parts, ATMEGA microcontroller, decade counters, or the shift resistors are same as the previously designed circuit. We can also render the three-dimensional design of this circuit. As we can see here, this is the 3D view of our designed PCB. These are some of the glimpses captured during our mock presentation and discussion. And now we will be talking about the future outlook in the next slide. There are a couple of things which can be included here. First of all, our goal was to implement the project in hardware platform, but unfortunately, due to the COVID-19 pandemic condition and continuous shutdown, we couldn't make it. In the circuits, stopwatch, timer, etc. could have been added. Incorporating alarm clock with reminder system can also be a potential future part. So in this project, we have demonstrated a Bangla clock along with the English one using Proteus software as the simulation platform and MicroC Pro as the coding platform. We have designed the Bangla fonts and displayed them via dot LED matrices. We also designed PCB layout so that the real life implementation in hardware setup can be done. With that, I would like to conclude our presentation. Thank you, everyone. Feel free to ask any questions.